Boom! An explosion of supersonic waves, interplanetary heat, dust, fumes. The Earth's atmosphere has been invaded by a cosmic rock the size of Everest. A few seconds ago, this rock, weighing trillions of tons, was hurtling towards Earth. It could fly from New York to Anchorage faster than you could fry yourself an omelet. This monster's name? The Chicxulub Incident. Epic name, right? 66 million years ago, it crashed into the Earth. Back then, dinosaurs ruled the planet, but not for long. The epic collision took place in modern Mexico, in the Yucatan Peninsula, right near Cancun, where the dinosaurs were vacationing. Well, probably not. Still, the huge space rock hit the ocean, but even all that water couldn't stop the inevitable. The collision caused a huge amount of energy to be released. The horror on a planetary scale had begun. Imagine a mini-sun lighting up the surface of the Earth with tsunamis the height of the Statue of Liberty bursting from the epicenter of the watery impact. Not good. The blast blew through the surface of the Earth. It was as hot as an oven and burnt everything in its path. The impact provoked a colossal earthquake and serious volcanic activity. A bunch of volcanoes simultaneously released hot lava and ash into the prehistoric skies. Millions of tons of ash and soot poisoned the air. This formed a huge ash cloud in the atmosphere, which blocked out the sun's rays for several years. The long winter had begun. Only there wasn't any snow falling from the sky, but rain made of sulfuric acid. Yes, the Chicxulub incident might just be the most important thing that ever happened in the history of our planet. Even more than YouTube. Back then, there were loads of volcanic eruptions, a lot of flammable oxygen in the atmosphere, constant temperature changes. It was the perfect and worst time for all of this to go down. So, how are we so sure about all this? Well, the asteroid left an absolutely huge crater on the planet's surface. Today, this scar is hidden under the Gulf of Mexico. Scientists found a lot of places on Earth with abnormally high levels of iridium. This metal is very rare on Earth, but it's in a lot of asteroids that scientists have examined. Scientists studied some 66 million-year-old rocks. In the layers of rock, they found dust, the same dust that comes from asteroids. This could only have happened if a huge asteroid had crashed into Earth. The catastrophe led to the extinction of not only the dinosaurs, but also the asteroid. It was so hot at the point of impact, part of the asteroid just disappeared. A lot of water vapor and carbon dioxide shot up into the atmosphere. But the biggest problem, sulfur. It got kicked up by the asteroid impact and flew up into the air. These tiny sulfur particles blocked out a lot of the sun's rays. Without the sun, a lot of plants disappeared and the climate eventually got colder. The immense heat turned stones into glass. Scientists call these things tektites. The energy of the impact threw them up into the skies. After a short flight, the tektites fell down to Earth. But it wasn't pretty. Rain fell too, only instead of drops of water, you'd have seen hot glassy fireballs. They bombarded the planet's surface for days. The tektites set fire to everything. Scientists found evidence of this all over the world, not just near the collision site. But a lot of things from back then are still a mystery. Some scientists think that Chicxulub wasn't even an asteroid. It might have been a comet. Asteroids are mostly made of stone and metal. Most often they kind of look like a potato. A comet contains rock, metal, and ice. Comets look like dirty cosmic snowflakes, complete with ammonia, methane, and carbon dioxide. Comets sometimes come from the Oort cloud. It's a huge cloud of ice and debris around our solar system. From time to time, comets break free from the pack and head towards our sun. According to scientists, this special comet flew right past Jupiter. The gravity of that huge planet accelerated the comet even more. It flew towards the sun, gaining more and more speed. The comet's outer ice shield started to evaporate, and it probably gave off a lot of dust and gas, which made it look like it had a tail. The sun's gravity eventually shattered the comet apart. One of the fragments flew through space and crashed into the Earth 66 million years ago. So, asteroid or comet? The truth is, we'll never know. What we do know is that the Earth was seriously unlucky to be in its path, and it was never the same again. The catastrophe stopped the development of 75% of life on Earth. Some bigger marine animals, like crocodiles, turtles, and fish, survived the impact. Out of all land animals, the only ones to survive were the ones that were, on average, smaller than the modern raccoon. That includes a bunch of special species of dinosaurs, the ancient ancestors of birds. Scientists believe they survived for two reasons. After the huge impact, it took a long time for plants to start growing again, and a lot of animals didn't survive. Most remaining animals didn't have enough food. But these dinosaurs had a beak. With its help, they could split open nuts and dig seeds out of the soil, so they survived. The second reason is that these lucky guys had bigger brains. Some people think that they were able to cooperate with each other and quickly adapt to the new conditions. Other life forms survived too. Fungi and mold survived underground and underwater. Gradually, the darkness cleared away, and ferns began to take over the lifeless landscape. After a few thousand years, forests started to reappear. The animals that survived were pretty much all inconspicuous and small creatures. They lived in burrows, safe from all that hot ash. Before the collision, mammals had lived in the shadow of dinosaurs. But with all the dinosaurs suddenly gone, things were about to change. Mammals were able to take over. They began to dominate life, at least on land. Back to the moment when everything changed. Turns out, it wasn't the size of the asteroid that made it so powerful. It was more about the angle in which it hit the Earth. If the angle of impact had been different, the dinosaurs might have even survived the catastrophe. So, what would that have looked like? Well, let's travel back, way back. Oh no, there's a giant asteroid heading for Earth. Oh, wait, never mind, it missed. Whew. There are plenty of earthquakes, tsunamis, and volcanic eruptions every day, but dinosaurs don't mind that much. No big deal. Fast forward a few million years, and most of these ancient lizards have changed and are now unrecognizable. Thanks to a couple of ice ages, many dinosaurs are now totally covered with feathers to protect them from the cold. Mammals exist, but they're few and far between. You see a lot of bats in caves. There are tons of rat-sized rodents in the forests. During the day, they hide in the undergrowth or in burrows. At night, they go out in search of food. There are no horses, no elephants, or other large mammals. Why become large and eatable when there are so many dangerous reptiles with huge fangs around? There are no whales in the sea. Parrots, hawks, and pigeons are nowhere to be seen. But pterodactyls 2.0 whiz past you constantly. Some are about the size of a helicopter, while others are no larger than a swan. There are plenty of primates, but they're in no hurry to climb down from their trees and walk on two legs. No venturing out into the savannah, no evolution into Homo sapiens. In this alternate reality, open spaces are very dangerous. But then again, so are forests and trees. Nowhere is safe. To get some delicious primate treats, many smaller dinosaurs learned to climb trees. This was already happening back in the Cretaceous period, right before that huge asteroid just missed Earth. Whew, that would have been an epic collision. Dinosaurs have grown wiser since that near miss. Some are even as smart as a modern chicken. A large brain uses a lot of energy, and that's not always a good strategy for survival. Safer to keep brains small and keep making those teeth bigger and pointier. So, theoretically, humans can survive an asteroid that has the potential to destroy entire planets. It won't be a walk in the park, though. Let's go back in time to 66 million years ago, in the late Cretaceous period. The Earth, before humans, where dinosaurs are thriving. The plants and animals are rich and diverse. You'd see a T-Rex chasing a Triceratops, or the massive Alamosaurus, one of the biggest animals to ever roam the planet, towering over the landscape. In Texas, they remember the Alamosaurus. And watch out for the Ankylosaurus, a living tank swinging its tail like a wrecking ball at any threat. As you're about to enjoy a quiet evening under the stars, a bright new light appears in the sky of the northern hemisphere. Now, a new star in the sky doesn't really stand out at first. It's just twinkling like the rest. But give it a few hours and you'll notice it's getting brighter. Check again the next night and boom, it's the brightest thing in the sky, outshining planets and even the moon. And finally, it horrifyingly outshines the sun. The star was the Chicxulub asteroid, which left a gigantic crater now called Chicxulub Crater in Mexico's Yucatan Peninsula. The asteroid enters the Earth's atmosphere at a blistering 12.5 miles per second. It blasts through 60 miles of the atmosphere in about 3 seconds. It falls so fast that even the air can't get out of its way. The air gets squashed and heats up to thousands of degrees in a blink. Before the asteroid even touches the ground, this super-hot air has already vaporized much of the sea where it's about to strike, near the Yucatan Peninsula. Then, in a flash, the asteroid smashes into the Earth, screaming over Central America with a loud boom that echoes everywhere. It doesn't just smash the ground, it makes the soil and rock flow like liquid. The asteroid digs a hole so wide and deep that it nearly touches Earth's inner layers and throws up dirt more than 20 miles high. At that exact moment of impact, the asteroid also turns its massive speed and weight into heat in a split second. It puts so much energy into the Earth that it makes molecules move faster than the surface of the Sun. This massive energy created a giant ball of plasma, superhot charged gas that includes bits of vaporized rock. This all shot out at incredible speeds. The shockwave from the impact and the heat turned the Earth around the crash site into gas instantly. This set off earthquakes all around the world. And it's not just the rocks flying around that you need to worry about. As they plummet through the sky, they rub against the air, heating up so much that they set fires all around the world. The heat they give off could be compared to an oven cranked up to its highest setting. This fiery shower causes most of the world's trees to burn down. The entire world is now on fire. Soon it changes everything. In a blink, dinosaurs were wiped out, making way for mammals to rise. And not only dinosaurs, 75% of species and big creatures disappeared, leaving behind only some small birds and critters. So, how could you, a human, survive something like that? Now, some animals made it back then. To survive, we need to learn from their resilience. The only birds that survive even in the toughest conditions are the ones nesting safely on the ground. Among the few larger animals that manage to dodge extinction, all have ways to deal with the heat. Some, like certain small mammals, snakes, and lizards, can dig themselves into cooler underground burrows. Others, like crocodiles and turtles, just hide in the water. So, if you're exactly on the other side of the planet when the strike happens, and you act super fast, you might just make it. Right now, the impact is about 10,000 miles away, but don't underestimate its power. As soon as you hear the loud boom, head underground as quickly as you can. And be careful, because you'll feel the earth shake about 30 minutes later. Hide in a deep cave, preferably with a narrow entrance. It would protect you from the falling debris, and the temperatures underground would be stable. Also, some caves have natural water sources, rivers or streams. You might also prepare for the not-so-great diet of insects, fungi, or poor small animals that also seek refuge in the cave system. But it's better than nothing. You also need to be extremely far away from any large bodies of water. Being near the ocean might seem like a safe bet during a massive asteroid impact because the sea can buffer extreme temperature changes. But the earthquakes trigger terrifying tsunamis, even in lakes or fjords. The asteroid's crash sets off not just one tsunami, but many, and they're as tall as skyscrapers. Within an hour, colossal waves between 600 and 1,000 feet high hit the Gulf Coast, slamming into places like Mexico and the southern United States, and flooding miles inland. These waves are so powerful, they even push rivers backward. These tsunamis continue around coastlines, reaching the east coast of the United States, and 6 hours later, they hit Europe, Africa, and the Mediterranean. By 15 hours after the impact, there isn't a coastline on Earth that hasn't felt the wrath of these waves. Well, let's say you survived the initial impact somewhere deep underground, but your troubles have only begun. The Chicxulub asteroid strikes a region loaded with sulfur. This sends 100 billion tons of sulfur and an enormous amount of water into the sky. The water vapor forms massive storm clouds. They start to rain acid. In colder places, huge snowstorms bury the land under feet of snow each day. The impact also vaporizes massive amounts of oil, throwing up 150 football stadiums worth of it into the air. This oil turns into a thick black soot in the stratosphere. It coats the Earth like black paint. And even when the acid rain calms down, this carbon stays up above the clouds and doesn't wash away. This sooty layer blocks out 90% of sunlight, plunging the Earth into a cold darkness that lasts for at least 3 years. The world cools down by about 50 degrees on average. Now, when you finally leave your deep cave, you must look for places where you won't freeze. The only spots spared from the frost are tropical islands like Madagascar, India, which was an island back then, and Indonesia. These places have surviving plants and animals, and they even continue to get fresh water, unlike most of the world. Everything else in the world looks like a huge nuclear wasteland. These tropical islands are safe spots during an asteroid apocalypse, but don't think of them as paradise. These places still only get about 10% of their usual sunlight and barely enough rain to avoid turning into deserts. In this chilly, gloomy setting, most food chains fall apart. If you want to survive, you'll need to bring lots of extra food with you, for the next 6 years at least. Now, some things are lucky enough to survive. Fossils tell us that freshwater ecosystems did well, so staying close to a river or estuary might be your best shot at finding food. You could come across turtles, crocodiles, and some fish. Animals like clams, snails, and small crustaceans that live in the sediment also manage to hang on. And while a bit warmer than everything else, these places are no walk in the park. You'd need to pack warm clothes to have any chance of survival. Now, if we add all this together, the best spot for surviving the Chicxulub asteroid would be Indonesia. It's a mountainous, tropical country that consists of several islands. There, you'll find bearable temperatures, a bit of rainwater, and a deep cave for shelter. This could protect you from the falling tektites, the intense heat, and even help you find something to eat in the rivers and lakes. But if you stumble upon any shrew-like creatures while scavenging for food, time traveler, please let them be. It's not clear how many survived the Chicxulub impact, and eating one could have unforeseen effects on the future of humanity. Like, don't eat your great-great-great-great-great-great-grandfather, right?
Let's go with the widely accepted theory that a massive asteroid hitting our planet wiped out the dinosaurs. It does make you wonder why mammals made it, though. One idea is that mammals were better prepared. Back then, they weren't the most popular creatures on Earth, but they were pretty diverse. They bred themselves into a huge range of species, and it might have saved them. Some said mammals survived because they were smaller, so they needed fewer resources. As they had to constantly hide from dinosaurs, they managed to survive in difficult environments, way before the hit. But let's say the asteroid never came, and it never damaged the environment the dinosaurs thrived in. It's safe to say our fauna would look different today. Take the mighty Titanosaur. It's considered the biggest land animal to ever exist, some reaching lengths of about 7 standard cars lined up. It had a neck so long that it would have needed a 2-story home just to fit. It also had a plant-based diet, so it ate from the ground, but from very tall trees too. There was nothing much left to eat for, say, the little Jeremiah, a mammal that lived roughly at the same time, but was as small as a popsicle stick. Let's take this thought experiment a bit further and imagine we have a time machine that could transport today's mammals to the time of the dinosaurs. Some scientists say they have gotten bigger, so there's a chance they could survive, right? They're also much more evolved in terms of their diets and skills. Others say definitely not. They couldn't survive, mostly because they're too small to compete with dinosaurs. An adult T-Rex was just about the size of a bus. It probably wouldn't waste its time trying to capture food that's human-sized, for instance. They'd probably be on the lookout for prey the size of a car, or even bigger, like an elephant. And it most likely wouldn't take them long to win the fight. Sure, a T-Rex might munch on something smaller too, but only if it's really hungry and has no other alternative. If we had no choice but to send some mammals back in hopes they could survive, what would be our best bet? Some say the chimpanzee could be a good candidate, as these primates build their sleeping nests higher up in trees. This might have kept them safe from the carnivore dinosaurs living on land. There's no real evidence of dinosaurs being able to fly, but we do know there might have been some reptiles that took to the sky for transportation, like pterosaurs, the flying lizard. These ones like to eat fish and smaller animals, but who's to say they wouldn't pick up a chimpanzee given the opportunity? Another good candidate might be the hyena. Today, the spotted hyena is the most common big carnivore in Africa, and it's highly adaptable. They could snatch up all sorts of prey by themselves or even in larger units. They can digest most parts of their prey, including the skin and bones. These animals aren't picky eaters, and they wouldn't mind chewing on parts that other creatures would gladly skip on. Not to mention, they'll eat fruits too if needed. Hyenas are overall healthy and sturdy animals, with some studies showing they hardly ever get health problems. But like any other animal on this planet, the hyenas also have their weaknesses. We still don't know why these creatures can't be found in Europe anymore. But some research suggests they found it hard to coexist with humans and wolves. Also, they're not very adapted to living in forests. Orcas might have been able to rub elbows with the dinosaurs too. These creatures also don't have any natural predators, which earned them the nickname the wolves of the sea. That's because they go out looking for prey the same way wolves do, in groups. Orcas may be related to dolphins, but we can hardly call them friendly, as there have been cases of them sinking ships on purpose. They're highly intelligent animals that spend time together and are very organized. They also do this thing where they often take down more prey than they're prepared to eat. It may be because they see this experience as training. Other theories suggest orcas are so intelligent that they look for food in advance, even though they're not hungry yet. It might also be because whenever they want something to munch on, they're looking for the best quality food there is. The reason why they might not survive in the dinosaur era, though, is the global temperature. Back in the Mesozoic era, our planet was seriously hotter, several degrees warmer than it is today. Orcas prefer living in colder waters, but you'll find them in all oceans and most seas. Ostriches are the no-brainer answer. Look at them. They're practically dinosaurs. They even have a long-lost dino cousin that lived in the Cretaceous era, called the Struthiomimus. Its name translates to ostrich-like because of its similar powerful and speedy legs, agility, and even feathers. On the downside, they might not be able to take down larger dinosaurs. The vegetation back in the Mesozoic era would have been different too. Conifers used to dominate land, and ostriches are known to be pretty picky eaters, so they might have had a difficult time finding food back then. There are plenty of reasons to send felines through that time machine too. In the Jurassic period, for example, there were plenty of slow-moving prey to eat and tons of hiding spots in the thick bushes. Felines are sneaky animals, have precise vision, and are extremely good at climbing. Some pack a punch for their size, making them fierce fighters. Lions are good contenders because of their speed and teamwork. They might be able to take down some decent-sized dinosaurs, like the Europasaurus, when working together. Leopards are really good at climbing trees, so they could snatch prey and enjoy it above the ground, where they might be safe from bigger predators. What might be their downfall is again the temperature difference. It was considerably hotter back then. Today's large mammals aren't equipped to deal with that extreme heat. Lions might be the kings of the savannah now, but it would be too hot even for them. If they ever want to grab a spiky-tailed herbivore for lunch like the Tugiangosaurus or Stegosaurus, they might be in for a surprise. One hit from their extremely powerful tail could cause some serious damage. Not to mention run-ins with raptors like the frightening Saurophaganax. The single most likely animal that might survive being roommates with the dinosaurs is the platypus. This quirky Aussie creature is one of those rare egg-laying mammals. It's a fan of freshwater and as close to a living relic as an animal can be. Scientists were able to trace its origin back as far as 120 million years ago. For food, it wields its sensitive beak to catch shrimp and worms underwater. When it dives, skin flaps cover its eyes and ears, so it becomes blind and deaf. But it still uses that beak like a high-tech radar. A grown platypus can even feast on half its body weight in a single night. Scientists have known for a while it shares many traits with reptiles, like its shoulder bones or the fact that it lays eggs. Other creatures that coexisted with the dinosaurs still exist today, just not mammals. Snakes made their way into our fauna in those prehistoric times too, as well as cockroaches and bees. Some species of sharks are even considered to predate the dinosaurs. And if we look at our entire planetary history, we'll see they survived 4 out of 5 periods of mass extinction. Horseshoe crabs have the nickname living fossils because their evolution was much slower than any other animal that we know of. Not because they're not smart, but simply because they found their perfect form much sooner. So they didn't need to make a lot of changes. They have a very rudimentary immune system, but it seems to work wonders. No wonder they stayed pretty much the same for over 400 million years.
Are you sure that it was an asteroid that caused the extinction of dinosaurs? There's this huge drama about why these horrifying creatures disappeared. It's a big deal in both science and movies. But what really happened to the dinos? How do scientists figure it out? And why does it even matter? Let's see. Let's take a trip back to England in 1842. There was a scientist named Sir Richard Owen. He was checking out some huge reptile fossils and noticed that 3 of them, Megalosaurus, Iguanodon, and Hylaeosaurus, had a lot in common. So he had this light bulb moment and decided to combine all these creatures into Dinosauria, which means terrible lizards in Greek. The scientists were studying dinosaurs and grouping them based on their looks. But then, Charles Darwin showed up and gave even a better idea. Turns out, species don't just appear out of thin air, they evolve. And now, everyone had to rethink how they were defining dinosaurs. They came up with a new idea called phylogenetic classification. Picture a big family tree with all creatures ever. Somewhere up there, we find Megalosaurus and Iguanodon. And we say all dino descendants come from their common ancestor. It's like tracing back your family tree, and if we go far enough, we find the ultimate dino ancestor. Sounds like a plan. But then, things got a bit complicated. When we talk about dinos, we've got the ones with feathers and beaks and the ones without. That's when we found out that birds are cousins to certain dinosaurs, maybe even evolved from them. After learning that, scientists had to look at the bird family tree and rethink the dino definition. In the end, they decided that birds are kinda dinosaurs, but not exactly. Confusing, huh? But in any case, now we have 2 groups. The first one is birds, and the other one is non-avian dinosaurs, which are extinct. That means now we have to reconsider our question. Instead of asking what caused the extinction of dinosaurs, it should be what caused the extinction of non-good dinos. The answer might seem simple. People often think of a gigantic space rock as the dino destroyer. It's probably the first thing that pops into your mind. Even Google and other search engines agree on this one, like best friends copying each other's homework. History teaches us that about 66 million years ago, dinosaurs totally vanished, except for the ones that became birds. Of course, the truth is more complicated. And not all dinos vanished in one go. Some went the natural way, and there were many extinctions here and there during their time on Earth. But the big event we're talking about looks like a movie scene change. Like suddenly changing the channel on a TV. One poof. and the Earth went from the time of dinosaurs to the time of mammals. Scientists call these time periods the Cretaceous and Paleogene. We even give this special event a nickname, the KPG, or KT extinction. Some even refer to it as the 65 million years ago event, even though the more correct number is 66 million years ago. We've got two main theories in the spotlight: asteroids crashing and volcanoes erupting like crazy. Let's talk about the asteroid idea. So, around 66 million years back, imagine a humongous asteroid smacking into Earth. This thing was about 6 miles wide, about as big as Mount Everest. It zoomed through the sky super fast, like a mountain going 100 times the speed of sound. And when it hit, it released a ton of energy. It crashed down in what's now southern Mexico, near a spot that's tied to the dinosaur extinction story, Chicxulub crater. Everything close to the impact was zapped into vapor in a snap. Picture the biggest energy burst in ages, like 1 billion years or more. Nothing near the crash site stood a chance. Next, there was the aftershock. As the fireball cooled down, the Earth's surface went bonkers. The ground twisted and shook, causing unimaginable earthquakes. The continents became huge, bouncy castles. And then, the stuff that got blasted up by the impact came raining back down like a rainstorm. Even if you weren't near the huge pieces falling in Mexico, you'd get hit by these smaller, super hot bits flying through the air. This made the air so toasty that forests burst into flames all around the world. Are you ready for more? Time for a massive tsunami. The ocean floor got all churned up, pushing waves inland around the Gulf of Mexico. But just imagine, even all that wasn't enough to destroy all the dinosaurs. For example, dinos in New Zealand were pretty fine, but we know that they all went extinct. So what happened to them? They felt a little rumble, and suddenly, the sky started getting all dark and gloomy, as if it was nighttime. And hold up, what's that? A blanket of ash is slowly creeping around the whole planet. Now, here's where the real drama happens. The big problem with the asteroid crash wasn't the instant boom you might think. It's all about the long-term effects. Imagine the stuff that got blasted up into the sky blocking the sunlight. Days turn into nights, and temperatures drop very sharply. A lot of plant-eating dinosaurs passed away, and hunters were having a great feast, but not for too long. Without sunshine, the food chain falls apart very quickly. Then, the ash falls back to Earth. Things go from bad to worse. Other nasty stuff starts floating around in the air like carbon dioxide. This carbon dioxide mixed with shattered seafloor bits makes the temperature go wild. The Earth was playing hot and cold all at once. That's when somewhere between 50 and 80% of dinosaurs said goodbye forever. What's even more sad is that this number only counts the species themselves. If we look at the number of individual animal lives lost, it's even higher. You might think that at least the poor mammals finally got their chance after the dinos left. But even mammals had a tough time. We are very lucky that a few brave mammals managed to survive this crazy chaos. The ones who made it were like the little champs with speedy energy systems, flexible diets, or secret hideouts. But this story is only one hypothesis. Next, we have the volcanism hypothesis. Volcanoes. These fiery mountains are used to spitting out molten rock and causing epic destruction. But surprisingly, this theory isn't about explosive eruptions. Nope. It's about something sneakier and slower. Around 1 million years before the Dino Doom, there's this big change happening under the Earth's surface. Way below where India's floating, a rock river starts forming, heating things up. And then, India gets hit hard. It turns into a sea of lava, like a fiery ocean. It's like a gazillion of dump trucks filled with lava slowly pouring out. These solidified leftovers are known as the Deccan Traps, like a super deep layer of hard lava covering a piece of land the size of France. And just like in our asteroid story, the real trouble comes from the air. For hundreds of thousands of years, sulfur dioxide spread like an unstoppable shadow. It was making the sky gloomy and the rain toxic. Food sources turned into poison, and oceans became acid baths. And then carbon dioxide took the stage. It was like a temperature button, flipping the Earth's climate upside down. It was a roller coaster of chaos. The ecosystems were stressed, food chains snapped, and species waved goodbye one by one. Both theories seemed pretty realistic. All the experts were having a big debate about which theory was correct and why the dinos disappeared. So, what is the real answer? Unfortunately, we don't know. Some scientists support one theory, some support the other one, and we're left scratching our heads. But hey, don't be too hard on the media or the scientists. They're all doing their best to figure out the mystery of the dinosaurs' disappearance. And maybe one day, we'll finally learn the real answer. So, stay tuned. Asteroids flying around is sometimes like a fierce game of dodgeball, where you never know when some of them can go in your direction. So we can just track the situation and hope for the best. To figure out the risks, scientists from different organizations have to study the positions and paths of the asteroids that come close to our planet, especially those that are at least 0.6 miles wide. And the good news is that none of these asteroids will probably hit us for at least the next 1,000 years. Phew! To give us an idea of their power, scientists did an experiment to simulate the impact of such a gigantic asteroid. The energy released from the collision would be a mind-blowing 100,000 megatons. That's like detonating 15,000 tons of dynamite. Also, if such a big asteroid hit us, Earth would cool down significantly because of all that debris that would go into the atmosphere and block sunlight. Plants wouldn't be able to get their fuel in this case, so we'd all be in trouble, both humans and animals. Thankfully, such mammoth asteroid impacts are quite rare. The larger an asteroid, the longer it takes it to collide with Earth. For example, it's estimated that asteroids with diameters of at least 0.6 miles strike our planet about once every 700,000 years. And if we're talking about even bigger ones that are 3 miles wide, well, those are predicted to come crashing down only once every 30 million years. Yay! But hold on. Don't get too relaxed just yet. Astronomers focus on really large asteroids because those are the ones that can kinda doom our planet if they hit us. Yep, you got it right. In a dinosaur kind of way. Even if one of them didn't erase us completely, the damage would still be enormous. So, there are still some asteroids wandering around that we need to keep an eye on to see how they might evolve over time. Scientists have a model of tracking them where they focus on the parts of an asteroid's path that come close to our planet to see if the space rock poses a risk to us. And it seems there might be one asteroid, 7482, 1994 PC1, 3,600 feet in diameter that might pose some danger. It's supposed to come closer to our planet in the next 1,000 years. And when I say risky, it means there's a 0.0151% chance of it coming within one Earth-Moon distance. It already passed by us in 2022, but we were lucky because it was far enough 1.2 million miles. I'd say we can relax when it comes to asteroid scenarios. For now, asteroids slamming into Earth would be new for humankind, but not for the planet itself. As I said, there weren't many of those big ones, but they still had enormous consequences. The first one that comes to most people's minds is, of course, the dinosaur asteroid as big as a mountain that struck our home planet around 66 million years ago, near Mexico's Yucatan Peninsula. It was chaotic. Global firestorms and tsunamis were all over the place. Dust was blocking out the sun, and vaporized rock released sulfur, which then led to acid rain and the acidification of the oceans. But there was an even bigger fella that came before that one. Around 2 billion years ago, a gigantic asteroid crashed into our planet and left a massive crater in South Africa. The one we know today as the Redefort crater. And it seems this asteroid might have been even bigger than we all originally thought. Twice as wide as the space rock that erased dinosaurs. The Redefort crater is confirmed to be the biggest visible crater on Earth, with a diameter of about 99 miles. It used to be even bigger when it first formed, though. Maybe even 155 to 174 miles across. It's hard to figure out its true size because the crater has been eroding for the past 2 billion years. Think of it like slicing off layers from the rim of a bowl. The diameter gets smaller with each slice. When the asteroid, 7 or 5 miles wide, that wiped away dinosaurs hit Earth about 66 million years ago, it caused massive destruction. Forest fires, acid rain, tsunamis, and so much ash and dust that it changed Earth's climate. This all made about 75% of life on our planet extinct. The asteroid that created the Redefort crater was not only bigger, but it also traveled at a higher speed, which means the consequences there would have been even worse. But it happened a long time ago, and living beings were different back then. Maybe it was some bacteria that didn't even notice that something unusual was happening. Earth is not the only one. Lots of impacts have happened across our solar system too. For example, in our close neighborhood. Moving to Mercury and its massive crater called the Caloris Basin. It measures about 950 miles across, which is more than the state of Texas. There's a ring of towering mountains around the crater which makes it look even more impressive. You can see different colors in the mosaic image of the Caloris Basin. They tell us more about the geology of the basin. The orange parts represent lava that once flooded the basin. These lava flows covered the original surface and added this specific orange hue. And after the lava flooded the basin on Mercury, smaller craters formed on top of the lava surface. These craters dug into the ground and uncovered the material hidden beneath the lava. Some of this material is blue in color. And this blue stuff could be a clue about what the original floor of the basin had looked like before the lava covered it. Venus, the hottest planet in our solar system, has a thick atmosphere that comes with a pretty good defense system against space rocks. It's so dense that it burns up most meteors before they even reach its surface. As a result, you won't see as many visible craters on Venus as on other rocky planets in our solar system. But Venus still has some scars that can tell us about some serious impacts that happened there. And one of the biggest scars we know about is Meade Crater. It's enormous, about 170 miles in diameter. The inner floor of this crater is relatively flat and kind of brighter than its surroundings. It's possible that the crater ended up filled with a mixture of melted rock after the impact, and maybe even lava from volcanic activity on Venus. Want to get an idea of what Earth might look like without its protective layer called atmosphere? Just take a look at the Moon. Its surface is littered with impact craters. This Tycho is one of the craters you'll easily notice on the Moon. When you look at the full moon, you can spot it as a distinct circle with bright rays that radiate outward, slightly off-center on the lower left side of the Moon. This crater, 53 miles wide, has a beautiful central peak in the middle that's topped with an intriguing boulder. The size of this boulder is impressive. It would fill about half of a typical city block here on Earth. When talking about craters, we definitely can't leave out Mars. The red planet has a much thinner atmosphere than Earth. When spacecraft approach Mars, they rely on the planet's atmosphere to slow them down as they enter it. And indeed, the atmosphere helps slow spacecraft down during landing, but it's still not thick enough to completely protect Mars from all those space rocks that are coming all the time. From July to September 2018, a dark spot appeared on the southern pole of Mars. It consists of two distinct patterns. A theory says that the bigger, lighter-colored blast pattern can be the result of an impact shock wave scouring the ice surface. The impact generated winds that spread out and scoured the ice. The inner blast pattern, which is darker in color, occurred because the impacting object managed to penetrate the thin ice layer. As it hit the surface, it sent dark sand and debris flying in all directions.
The sun is rising, lighting up the trees, swamps, and massive plants of the Yucatan Peninsula. It's 66 million years before today and the last days of the Mesozoic era. The peaceful world doesn't know yet that a rock the size of a mountain is hurtling toward Earth at a speed of more than 40,000 miles per hour. It looks like a fireball. It's growing larger and larger with every passing minute. Soon, it seems bigger than the sun. Dinosaurs roaming the prehistoric Earth don't know yet that they have to run, hide, and save themselves. Not that it's going to help. The asteroid crashes into the planet. The force of the collision is so powerful that the space visitor doesn't stop until it gets through Earth's crust to a depth of several miles. The impact leaves a crater that's more than 100 miles across. Thousands of cubic miles of solid rock instantly turn into vapor. The crash sets off a series of natural disasters that erase 80% of life on Earth. But I'll tell you all about it a bit later. The creatures that were close enough to see the crash don't survive for longer than a few seconds. Even closer to the impact crater, the ground is covered with thousands of feet of hot ash, grit, and rubble. Several seconds later, everything for miles around, grass, trees, bushes, bursts into flames. What doesn't burn down within the next several minutes after the collision faces a different, even more terrifying problem. It turns out the asteroid that wiped dinosaurs off the face of the Earth also produced a monstrous, largest ever tsunami. A recent study claims that it was thousands of times larger than any wave people have ever seen. The Chicxulub asteroid, as we now know it, is believed to have come from the outer reaches of the solar system. This space body was at least 6 miles across. It crashed into the shallow seawaters near the Yucatan Peninsula. This impact was so powerful that it left its signature on the face of the planet. In 2021, researchers found out that the collision had carved mega ripples into the Earth's crust in the region of modern-day central Louisiana. An even newer study suggested that the asteroid also triggered a tsunami so devastating it eroded seafloor sediments half a world away. The team of scientists even remodeled the events of the first 10 minutes after the impact. And the model showed that the asteroid had produced waves up to 30,000 times greater than one of the largest tsunamis people have ever recorded. I'm talking about the Indian Ocean tsunami that hit Indonesia in 2004. The collision displaced so much water that it created a wave almost a mile high. And of course, all that empty place didn't stay empty for long. The ocean gushed back to fill the crater, but in the process, it only ricocheted off the crater's rim, which produced even more waves. After that, tsunami waves that were more than 33 feet tall traveled around the world at the speed of 3 feet per second, lashing at all coastlines on their way. No wonder the largest and fastest moving waves occurred near the impact area in the open waters of the Gulf of Mexico. Those rose more than 330 feet tall and moved at a speed 10 times greater than the more distant tsunami waves. If we talk about the greatest tsunamis in the recorded history of humanity, Krakatoa's volcanic eruption in 1883 is worth mentioning. It produced the loudest sound ever heard on the surface of the planet. It also created a tsunami wave that was as tall as the Statue of Liberty. Another devastating natural disaster was the Boxing Day tsunami that occurred in Indonesia in 2004. It was caused by an undersea earthquake that started in the morning. Its tremors caused a series of tsunami waves, and the largest reached the height of the Arc de Triomphe in Paris. Unzen volcano megatsunami started after a powerful volcanic eruption triggered a landslide from a 4,000-year-old lava dome. It swept through the city of Shimabara and reached the sea, setting off a mega tsunami. Its largest wave was half as tall as the Space Needle in Seattle. One of the worst natural disasters in the world was the Viant Dam megatsunami that happened in Italy. A landslide dragged 9 billion cubic feet of forest, soil, and rock into the lake. A colossal dark wall of water covered the sky over a tiny village at the bottom of the Viant Dam. Then, with a deafening roar, the wave overtopped the edge of the dam, taking out everything in its path. The height of this wave was greater than the height of the Golden Gate Bridge. Another megatsunami occurred when the upper 1,500 feet of Mount St. Helens in the U.S. collapsed during an eruption, causing a massive landslide. A part of this avalanche plunged down into Spirit Lake. This pushed the lake's water into a series of waves almost as tall as the Eiffel Tower. One of the worst disasters of this kind happened in Latoya Bay in Alaska in 1958. A landslide caused by an earthquake created a wave that was one of the largest ever recorded. It surged over the headland and washed away trees, plants, and soil down to bedrock. The wave reached more than half the height of the Burj Khalifa, the tallest construction in the world. And of course, when we speak about the tallest tsunami waves ever, we must mention the Molokai megatsunami that occurred in Hawaii in 1946. A third of the East Molokai volcano caved in and collapsed into the Pacific Ocean. This caused a tsunami the size of the second tallest building in the world, Shanghai Tower, about 2,000 feet. The waves were so tall and powerful that they reached Mexico and California. But all these disasters pale in comparison with the tsunami that hit the Yucatan Peninsula about 66 million years ago. Anyway, let's get back to the other consequences of the collision. Shortly after the asteroid had smashed into our planet, earthquakes started to shake Earth like never before. Their power was equivalent to all the earthquakes that have happened on the planet for the last 2 centuries, as if they were going off simultaneously. A bit less than an hour after the collision, a gust of wind whipped through the area at a speed of 600 miles per hour. It flattened everything that was still standing and scattered debris for miles around. A bit farther from the direct impact zone, the sky started to darken dramatically. What looked like shooting stars was actually debris raining back on the planet. Glowing ominous red, they re-entered Earth's atmosphere and emitted infrared radiation. During the first hours after the crash, the sky was totally dark. Later, it started to get lighter, very, very slowly. For the next couple of years, it looked like something between a cloudy day and twilight. Many plants didn't survive this dimness and the absence of light. More than 75% of species on Earth soon disappeared. The ash stayed in the air for months. That's why, when it rained, the water became highly acidic. Fires kept raging. They produced tons of toxins that destroyed the ozone layer, at least for some time. The gases and particles that were flung into the atmosphere blotted the sun out. This caused temperatures to plummet by over 60 degrees Fahrenheit. Lots of plants and animal species that managed to survive the impact itself couldn't stand these new hostile conditions. Earth was in for hard times. Interestingly, some research claims that after the catastrophe, the southern hemisphere managed to recover twice as fast as the northern hemisphere. What could explain this phenomenon is the season when the asteroid hit Earth. If it had happened in the northern hemisphere's springtime, then all flora and fauna there would have been outside, searching for mates and food. While in the southern hemisphere, animals would have been preparing for the cold season, slowing down and making shelter for winter. But so far, it's just a theory. There's no proven explanation so far. Stay tuned to this channel for updates.
Asteroids aren't as rare on our planet as we may think. About 17,000 of them visit us every year. You've probably seen at least one in your life. For example, if you've seen a shooting star. They leave these bright tails behind them as they pass through Earth's atmosphere. Of course, they only look beautiful in the sky. If they reach the ground, the consequences would be catastrophic. Luckily for us, most of them explode 30 to 50 miles above the surface. Their mass is too small for them to withstand such a journey to the end, so most of them remain harmless to us. But we shouldn't underestimate them. Let's start with the smallest ones. 1 to 3 foot high asteroids are about the size of a person. They're too small to cause any real damage. Most often they explode in the atmosphere, without even reaching its lower layers. But at the same time, they splash up tons of energy over the surface every time. 13 to 15 foot asteroids, the height of giraffes and mammoths. These larger meteorites come to us less often, once a year and a half. Like the previous ones, they, fortunately, don't pose a serious threat, but they splash out much more energy. 30 feet, the height of a 3 to 4 story building. They visit us once every 10 years, and now we're talking seriously. It throws out a wave that could demolish an entire city. I think you understand how catastrophic the consequences would be if this asteroid touched Earth. 65 feet, multi-story building. They like to visit Earth once every 60 to 70 years. Good news, it explodes at 12 miles above the ground. Its released energy could destroy an entire region if it touched the ground. Bad news, such an asteroid has already visited us recently, and the consequences were pretty rough. It all happened in a city called Chelyabinsk. On February 15, 2013, at about 9:20 a.m. local time, the giant slowed down in the Earth's atmosphere and then broke up into small pieces at 14.5 miles above the Earth. These pieces then flew in different directions. It shattered the windows all over the city and damaged many buildings, including people's houses, schools, and others. It took a while to repair everything, and the scale of this destruction was quite serious. As a result, there were 1,615 injured, but fortunately, no casualties. At least we're safe for the time being. The next such asteroid may come to us only in the 2070s or 80s, and no one knows where exactly it wants to land. Now let's move on. 300 feet. This is the height of the Statue of Liberty together with the pedestal. Such a giant can be seen every 4,500 years, and this is the first asteroid on our list that may literally crash into Earth. The consequences are disastrous. Not only may it demolish an entire city, but it can also set fire to neighboring areas. Well, some people even witnessed such a meteorite land on our planet. The notorious Tunguska meteorite is the biggest asteroid disaster that people have ever seen. It all happened on June 30th, 1908 in eastern Siberia. The meteorite was bright, like a second sun, and people felt the heat wave when it just approached the Earth. It exploded near the river. Fortunately, the whole area was surrounded by taiga, and there were no big cities nearby. But even there, it immediately destroyed a lot of trees. Serious forest fires broke out. The sound of the explosion was heard by people hundreds of miles around. At tens of miles around, all the houses' windows broke. The magnetic storm that resulted from this collision lasted 5 hours. The consequences were truly disastrous, but perhaps this is not the worst thing that awaits humankind. 99942 Apophis, 1,215 feet. It's slightly bigger than the Eiffel Tower. This meteorite, as scientists discovered in 2013, will be our next guest. Collisions of such force occur in about 100,000 years, and this one is gradually approaching. The force of such an explosion is equal to the force of the catastrophic eruption of the Krakatoa volcano in 1883. This eruption is considered one of the most destructive in history. It caused a terrible tsunami. 165 cities and settlements were completely destroyed, and another 132 were seriously damaged. People all around the globe could feel the consequences of this eruption, at least to some degree. Such an asteroid could leave a 3.5-mile crater, and this is one we'll face in the distant future. But calm down, no need to panic yet. By 2070, the meteorite will be almost 174 million miles away from us. It still has a very long journey ahead of it, so we're safe for at least 100 years, or even more. Besides, our planet has survived something even worse. 3,280 feet. This is higher than the tallest tower in the world, the Dubai Burj Khalifa Tower. Such collisions occur once every 500,000 years. We're not sure when such a collision occurred the last time. 70% of our planet is covered with water. If such meteorites fell into the ocean, it would be extremely difficult to find their traces. But we can assume the possible consequences. The wave would have swept across the entire hemisphere. The crater would be about 9 miles in diameter, and that would be a complete disaster. The last event of such a force happened 26 to 28 million years ago. It was an eruption of the supervolcano La Garita, which is located in the southwest of Colorado, USA. It was one of the most powerful known supervolcanic phenomena in history. During this monstrous eruption, a significant part of the current state of Colorado was destroyed. Scientists are still not sure how far the ashes have spread, but there was an even bigger meteorite in the history of mankind. The consequences of that impact were irreversible for an entire species of animals. I think you know what I'm talking about. Chicxulub meteorite, the thing that wiped the dinosaurs off the face of the Earth. This happened about 66 million years ago. These collisions in general happen about every 500 million years. The height of the Chicxulub meteorite was 12.4 miles. It's so high that when it touched the ground, it could reach the stratosphere. Even looking at the 124-mile diameter crater left by this meteorite, you can understand how huge it was. When it collided with the Earth, millions of tons of energy were released. This is an unimaginable disaster. It fell at a very steep angle, creating a giant cloud of dust and chemicals that spread around the world. This dust had a very thin layer, but also a mass of 50 trillion tons. The shockwave swept across the entire planet. It caused several earthquakes. Volcanoes began to erupt actively. Forest fires broke out everywhere, all over the world. The amount of soot and carbon dioxide released into the atmosphere is invaluable. The Earth was closed from the sun for several days. Darkness reigned all over the planet. planets couldn't produce enough oxygen, so there was nothing to breathe. The temperature on the continents and in the oceans dropped by an average of 50 to 90 degrees Fahrenheit. Sounds horrific, doesn't it? And, of course, it caused one of the greatest extinctions in the history of the Earth's biosphere. Amazingly, the Earth was able to recover after such a catastrophe. This event became the boundary between the Mesozoic and the Cenozoic eras. So now, those who wondered, how could a small meteorite destroy all the dinosaurs, probably understand the answer. Perhaps the largest collision in the history of our entire planet was not a collision with a meteorite, but with an entire planet. This happened many, many billions of years ago. Theia, as this hypothetical dwarf planet was called, crashed into our Earth, releasing an incommensurable amount of energy, just quadrillions of fuel. The Earth then instantly turned into a giant fire, and it was this collision that led to the creation of the Moon. All that sounds terrifying, I know, so let's just hope that you and I will never see anything like this.